Hi everyone, this is Julia. I'm going to be walking through Lab 6, Abstract Data Types and Dictionaries, as an online resource for this week's lab. So we're going to be working through some of the problems on this assignment, and we're going to get started thinking about how to solve them and ways to think about the topics that we're introducing in this lab. So I hope you find it helpful, and we're just going to get started with abstract data types. Alright, so data abstraction is a powerful concept in CS that allows us programmers to treat code as objects. So for example, car objects, people objects, and so on and so forth. So the main idea is that programmers don't need to know how code is implemented in order to use it. So for example, you might have used this function throughout the semester, the stat sort, in order to sort a list. And notice here that you can just use the function without knowing what the code is underlying it. So unless you were to actually go into, Python's source code, you don't have line by line the code that actually makes up this function. But you do know how to use it, and it works just fine without knowing the nitty-gritty details of it. So that's the abstraction in this example that allows us to use something without knowing the full story or the background behind it. And as an example in real life outside of code, an analogy would be driving a car. So the average human usually doesn't know how a car is made or how to build an engine or any sort of thing like that. But they do know how to drive a car by turning it on and pressing the gas pedal and turning the wheel and so on and so forth. So that's the abstraction in that example, where we can use the car and drive it just perfectly without knowing how the car is made or how the manufacturer actually built the car. Alright, so going back to the CS world of things, we define an abstract data type to be two groups of functions. So we have the constructors. Actually, let me highlight this. Constructors and the selectors. So the way I think about it, or the way I like to think about it, is that really an ADT, or abstract data type, is a way of organizing functions to represent an object. And we typically classify these functions into two groups, constructors and selectors, because we have a constructor to make the object and selectors to retrieve some information from it. So the details and all of the data that's behind this abstract data type. So say that we have an ADT called city, and the city object will hold the city's name, its latitude, and its longitude. So to create a city object, you would use a constructor, which is just a function, but we're giving it this classification as being a constructor function. And this constructor is called makeCity. So when you pass it a name, a latitude, and a longitude, it will give you back a city. So remember here that you can't assume anything about the makeCity function because we're not given the code for it. But we can still use it and trust that it will give us back a city object. And now, to continue in the example, you might have selector functions called getName, getLat, and getLongitude. And if you were to use all of these together, you can make a city, and then get its name, and then similarly you can get the latitude and longitude. Okay, so we haven't really said anything about the code that's behind these functions, but just to sort of complete the story, if I were to actually make these functions, it could look something like this. So it's not guaranteed that it will look like this, but this is one way of implementing the 3 functions. So I might say def make city. Let me move this over. Name, lat, long. And then let's say it's just a list. It returns just a list. So in this example, if this were really the implementation, the city is just represented by a list. And in order to get the name or the latitude, we could define a selector function. So note this is example of a constructor. And then this should be an example of a selector. So we might say def get name, and it passes in a city. Well, in this example, notice that the name is going to be the first element of the list. So we can just say return city 0. Alright, so that should give us the name because we're assuming, well, we're not assuming. In this case, if we are the implementers of the city abstract data type, we know that the city is represented by a list, and we know that the name comes first in the list. So we can say city of 0. But when we're on the other side of the abstraction barrier, and we're not the people making these functions, we can't assume anything about the code inside these functions. We're just given these headers, and we know that this one over here makes a city, and this one over here gets the name of it. So, yeah, you can't assume that it's in a list format, because it could be anything. And that's the whole point of the abstraction, is that you don't really get to see the code or know what it is. But just as a way to elucidate this topic, here's how you would actually make this abstract data type as an example. Alright, so moving on. Alright, so just to hone this in, we don't need to know how these functions were implemented. But as sort of a guideline, I just put this example, just in case you were curious about what these functions would look like. And later on in the lab, you'll actually make your own. Okay, so, right, so it's okay if the end user doesn't know how the functions were implemented, because we're trusting that they work, and we're trusting that we know the inputs and the outputs. So no inputs and outputs. So example, input is city, and then output name. Alright, so actually we can look at this distance function and try to think about how we might go about it, or go about solving it. So we're now going to use the selectors from the city example in order to calculate the distance. So if you have 2 coordinate pairs, the x1 and y1, x2 and y2, if you calculate this formula, it will give you the distance. And this is just your regular mathematical difference of 2 points on a grid. So whenever I code anything, I always like to look at the doc test for help. And you can see in this doc test example that we have 2 cities. And this will be, or these 2 things will be your points of interest. And so what you want to do is take these 2 pairs of coordinates and find the distance between them. And make sure that you're using some of these selectors over here. Oops. Because we're assuming that this is part of the city abstract data type. All right, moving on to closer city. So closer city is going to take in latitude, longitude, and two cities, and return the name of the city that's relatively closer to the provided latitude and longitude. So this is a little bit similar to distance, except that we're looking at the relative difference between the two cities and one point of interest. So remember that you can use the selectors and constructors that were introduced above, which are these over here. And you can also use distance. So in making the code for number 2, you can also use the code for number 1. All right. So remember that the point of data abstraction is that we don't know how this ADT is implemented. Just to repeat myself a little further, sorry if I repeated it too many times, the make city example here is not guaranteed, so you don't know for sure it's a list, and you shouldn't assume anything about it. So this is just an example, and over here you're pretending like you don't know at all how this ADT could be implemented. So you just have the functions get name, get lat, get long, and distance. All right, and we can walk through this doc test too. So we have one city, Berkeley, and this is its lat, it's long, I believe it is, let me see, yes. So the second one is lat, the third one is long, and then we also have Stanford, and when you pass in these 2 points, it will give you Stanford because Stanford should be closer to these 2 coordinates than Berkeley is. And a similar argument is made for Bucharest and Vienna, except Bucharest is going to be closer in this case. Okay, so I hope you see that the distance function will be very helpful in this case because we're working with distances here again, except that we're not comparing 2 cities to each other, but 2 cities to some other point on this map grid. Okay, moving on to number 3. So number 3 is not actually a standalone question, but it's going to test whether you followed the abstraction barriers in number 2 and number 1 correctly. So what that really means is that it's going to check whether you assumed anything about the ADT. Because when you cross the abstraction barrier, what that usually means is that you said something like city of 0, if city is some list. And you do not want to do this because all you should be using is the get lat and then get long. I think there's a underscore between them. Yes, get lat, get long, get name, and distance. Because remember, you cannot assume anything about what city looks like as an abstract data type. So you don't know if it's a list or a tuple or a dictionary or whatever. Alright, so as long as you stick to your functions, your constructors and selectors, you should be good to go. But just to be clear, distance is not a constructor or a selector. In fact, it's a function that uses selectors. But these are selectors. Alright, so moving on to dictionaries. So dictionaries are very similar to lists, except that they include mappings. So normally lists are organized like 0, 1, 2, 3. And notice they are ordered by their indices. Well, dictionaries have a different kind of ordering because what they are really just a list of mappings.